Hi, in this video, I'm going to take you through some of the fundamentals of coordinate geometry. Now, coordinate geometry is not an often asked topic in general aptitude entrance examinations like the CLAT or SLAT or SET General or the exams for mass communication, liberal studies, and so on. But questions from coordinate geometry can be expected in the exams of IPM 80 of IIM Indore or NPAT for Narsing Monji. So in this video, I'm going to take you through the fundamentals of coordinate geometry and show you how some of these examples can be solved. So what exactly is coordinate geometry all about? The word coordinates is often used to indicate the location of a place. For example, when we talk about the latitude and longitude to mark a specific space, a specific place on a map, those are the coordinates of the point. So let us now take that there is a space and we mark the x and the y axis. So the horizontal is called the x axis and the vertical is called the y axis. This is our reference point. The point where the x and the y axis meet is known as the point of origin. So this point is marked by the coordinates 0, 0. Starting from the common point, on the horizontal x-axis, the points on the right are marked by 1, 2, 3, 4, 5, 6, and so on. These integral points are nothing but marking the location. Now you can mark them whichever way. Similarly, on the left hand side, we mark -1, -2, -3, -4, and continue. On the vertical axis, the points on the top side are marked by the positive integers 1, 2, 3, 4, and so on, while the points on the lower portion are marked by the numbers -1, -2, -3, -4, and so on. Now, supposing I have marked a point here and call this point A. The position of point A can be indicated by its reference to the x and y axis. This point corresponds to the number 5 when projected on the x-axis. So the x-coordinate for this point is 5. Similarly, when this point is projected on the y-axis, it corresponds to the number 3. So its y-coordinate is 3. So when I say A, the coordinates of point A are 5, 3, it means it projects the number 5 on the x-axis and the number 3 on the y-axis. Similarly, supposing I mark the point B here. So what will be the x and y coordinates for this point? Well, projecting it on the x-axis, we can see that it corresponds to the number -5. Similarly, when I project this point on the y-axis, we can see it corresponds to the number -2. So the coordinates of B are -5 and -2. Now, supposing I want to mark a point C with the coordinates 4 and -3. So the x coordinate is 4. So I will draw the line on the x axis on 4. The y axis point -3. I can join the line 3. So the point where these two meet, this particular point will be C with the x coordinate corresponding to 4 and the y coordinate corresponding to -3. So this is the coordinate system, right? So we can use certain terms to indicate the numbers. In coordinate geometry, the point 0, 0, where the two points meet, is called the origin. Then the horizontal line is known as the x-axis. The vertical line is known as the y-axis. Now, we can also see that the x coordinate, this distance, this point is known as the ordinate, right, corresponding to the x-axis. And this point is also known as the abscissa. So, to repeat, for any point in the plane, the distance from the y-axis, that is along the horizontal scale, is called the x-coordinate or the abscissa. The distance from the x-axis, that is along the vertical scale, is the y-coordinate, also known as the ordinate. So the numbers 5, 3, minus 5 comma minus 2, 4 comma minus 3. These are known as ordered pairs. The first number always indicates the x coordinate and the second number always indicates the y coordinate. Now, there is a concept called the slope of line. The slope of a line is nothing but the tan of the angle made by the line with the positive x-axis. So to make things clear, let us say that we have our x and y axis marked here, right? Now supposing I have a line like this. Let us say this line is L. Now the x-axis, if I extend this line, then this line intersects the x-axis. Let us say that this angle is theta. So if theta is the angle made by the line with the positive x-axis, then the value tan theta is known as the slope of the line L. So the slope of line L is nothing but tan theta. Now, why is it called slope? So tan theta, how do we derive? So supposing this point and this point are the 2 points, right? So I can draw a line here, I can draw a line here. This is nothing but the opposite and this is the adjacent. Now, this opposite and adjacent is for the right angle triangle ABC. So this is theta. Tan theta is nothing but the opposite upon the adjacent. So if I'm able to find out the values of these two lengths, then I can find out the slope of that particular angle. So let's take this example, right? I have drawn the x and the y coordinates. Now supposing I draw this line, the coordinates x1, y1, and the coordinates of this point x2, y2. So what does that mean? The x coordinate, the value here is x2, the value here is x1. Similarly, if I'm to draw this line, here it is y1 and this particular point is equal to y2. If I draw the triangle ABC, then the length AB is nothing but the entire length y2 minus this length y1, y2 minus y1. Similarly, BC is equal to this entire thing x2 minus this x1, so x2 minus x1. Also, if this is the angle theta, then tan theta is opposite upon adjacent AB upon BC. So we get tan theta is equal to y2 minus y1 upon x2 minus x1. The value of tan theta, where theta is the angle that the line makes with the x-axis, is given by the formula y2 minus y1 upon x2 minus x1. So I'm giving you a few examples to solve. For example, what is the slope of the line joining 2, 3 and 4, 5? So 2, 3 and 4, 5. So if I compare this with x1, y1 and x2, y2, then the slope of the line passing through these points is y2 minus y1 upon x2 minus x1. So y2 minus y1 upon x2 minus x1. The answer to this example is 1. Supposing I have to find the slope of the line joining the points minus 2, 4 and 1, minus 3, then the slope again is given by the formula y2 minus y1 upon x2 minus x1. So in this case, this is x1 and y1, this is x2 and y2. So y2 minus y1 upon x2 minus x1 is equal to minus 7 upon 3. So the slope of this line is minus 7 upon 3. I hope you are able to calculate the values of the remaining illustrations which are given on this particular screen. Now, there are certain things that you should know. Supposing there are two lines given. Let us say this is line L1 and this is line L2. Supposing slope of the line L1 is given by M1 and the slope of the line L2 is given by M2. So if L1 is parallel to L2, then the slope of the two lines will be same. So if the slope of two lines are equal, it means that the lines are parallel. Similarly, supposing I have two lines, let us say x and y, and x is perpendicular to y, right? The slope of the line x, let us assume, is x, mx. Slope of the line y is my. So if x is perpendicular to y, then mx multiplied by my will be equal to -1. So for two lines which are perpendicular to each other, the product of their slopes is -1. So if the slopes are the same, then these lines are meant to be parallel. If the product of the slopes is -1, then these lines are said to be perpendicular to each other. Now, in coordinate geometry, we form equations for lines. So we can say that the general equation of the line is given by ax plus by plus c equals to 0, right? So the equation of the line joining x1 y1 and x2 y2 can be formed by using the formula x minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. This is one of the most important equations. When you know the value of two coordinates, 2 points, the equation of the line which is formed by joining these 2 points is given by this formula. Let us take a look at the equation of the line joining the points -2, 3 and 5, 6. So it is given that -2, 3 and 5, 6 are the points which are to be joined. The equation is given by x minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. Now, these are x1, y1 and these are x2, y2. So substituting the values, we get x minus -2 upon -2 minus 5 is equal to y minus 3 upon 3 minus 6. Simplifying, we get x plus 2 divided by -7 is equal to y minus 3 upon -3. Negating the negative sign on both sides, we get 3x plus 6 is equal to 7y minus 21. So we can write 3x minus 7y plus 27 is equal to 0. As we have seen before, the standard formation is ax plus by plus c is equal to 0. So the format has to be 3x minus 7y plus 27 is equal to 0. This is the proper format in which we will be writing the equation of any particular line. Now, supposing you are given just one coordinate, but you know the slope of the line, then the equation of the line with slope m and which is passing through x1, y1 as the coordinates is y minus y1 is equal to m into x minus x1. Y minus y1 to m to x minus x1 is the equation of a line with slope m which passes through the points x1 and y1. Let's take the example of -2, 3 and 5, 6. Here, first we will find slope, which is y2 minus y1 upon x2 minus x1. 6 minus 3 upon 5 minus -2. So that is equal to 3 upon 7. Y minus y1 is equal to m into x minus x1. So y minus y1 is equal to m into x minus x1. 7y minus 21 is 3x plus 6. So 3x minus 7y plus 27 is equal to 0. We get the same equation even by using the format of y minus y1 is equal to m into x minus x1. Now, y is equal to mx plus c is the equation of the line when we know the slope m and we know the point where it intersects the y-axis, that is the y-intercept called c. If it intercepts the x-axis at a and y-intercept is b, then the equation of the line is x upon a plus y upon b is equal to 1. Now, the perpendicular distance from a point x1, y1 to the line ax plus by plus c is equal to 0 is given by this formula mod of ax1 plus by1 plus c upon root of a square plus b square. So supposing we are given upward line, the equation of this line is ax plus by plus c is equal to 0. Supposing this is a point x1 comma y1. So to find the perpendicular distance from this point to the line, this perpendicular distance, we will use the formula ax1 plus by1 plus c, the whole divided by a square plus b square. Guys, remember the modulus gives you a positive value. The distances are always measured in positive units, so the modulus is very important. Consider this problem. You have to find a point on the line x plus y is equal to 4 that lies at a distance of 1 unit from the line 4x plus 3y is equal to 10. So we have our line 4x plus 3y is equal to 10. If you want to compare it with the standard format ax plus by plus c is equal to 0, then we rewrite this equation as 4x plus 3y minus 10 is equal to 0, where we get the value of a is equal to 4, b is equal to 3, and c is equal to minus 10. Now, we have to find the points on the line which are at a distance of 1 unit. We already know that the formula of perpendicular distance. So, we put ax1, so we get 4x1 plus 3y1 minus 10, the whole divided by root of a square plus b square, and this gives me the perpendicular distance which is given to be 1. So solving this, we will identify that we'll solve this. What is x1 y1? We are assuming x1 y1 are the points which are at a distance of 1 unit. So first we can write the modulus 4x1 plus 3y1 minus 10 divided by root of 25, that is equal to 5 is equal to 1. So 4x1 plus 3y1 minus 10 upon 5 is equal to 1, or 4x1 plus 3y1 minus 10 upon 5 is equal to minus 1. Why did we take positive and negative values? Because of this modulus function. When you open the modulus, you have to equate it to both plus and minus 1. So either 4x1 plus 3y1 minus 10 is equal to 5, or 4x1 plus 3y1 minus 10 is equal to minus 5. So now we have got two set of equations. Simplifying this further, either I can say 4x1 plus 3y1 minus 15 is equal to 0, or 4x1 plus 3y1 minus 5 is equal to 0. Now, this line, now we got two equations. We also know the point x1, y1 is lying on x plus y is equal to 4, because that is given in the question. So if x1, y1 is lying on the line x plus y is equal to 4, then we get x1 plus y1 minus 4 is equal to 0 in both the cases. X1 plus y1 minus 4 is equal to 0. So now you have two set of equations. When you solve these two set of equations, you will get the value of x1, y1 as either 3, 1, or the value of x1 and y1 as minus 7 and 11. So we have two possible values, because as you can see that if a line is there and a point is at a distance of 1, it is possible that this point may be on either side. So there can be 2 points which are at a distance of 1 unit. So we get two possible answers to this particular question. Now, supposing we are asked to find the perpendicular distance between two parallel lines. Now we know that parallel lines have the same a and b values. The only thing which changes is the value of c. So if ax plus by plus c1 is equal to 0 and ax plus bx plus c2 is equal to 0 are the two parallel lines, then the perpendicular distance between them is given by the formula modulus value of c1 minus c2 upon under root of a square plus b square. The difference of their intercept values divided by root of a square plus b square. The positive value is the perpendicular distance between the two parallel lines. Now, the question asks, if two sides of a square lie along the lines x plus y minus 1 is 0 and 2x plus 2y minus 3 is equal to 0, find the area of the square. Now, I know that the first line is x plus y minus 1 is equal to 0. The second is 2x plus 2y minus 3 is equal to 0. Now, I can manipulate this dividing it by 2. X plus y minus 3 by 2 is equal to 0. So now take a look at these two equations. The two equations have the same values of a and b when comparing it with ax plus by plus c is equal to 0, right? And only the value of c changes. That means these are parallel lines. So if these are two parallel lines, then the value of the perpendicular distance between them is given by the formula which we have just seen, c1 minus c2 divided by under root of a square plus b square. So c1 is minus 1, c2 is minus 3 by 2, the whole thing divided by a square, that is 1 square, plus b square, that is 1 square. So this is equal to minus 1 plus 3 by 2 divided by root of 2. So minus 2, that is 1 upon 2 2. So this is plus or minus 1 upon 2 root 2, but because the modulus makes it positive, so now we know that if there are two parallel lines represented, then this perpendicular distance between them is 1 upon 2 root 2. So when I form a square between these two parallel lines, this value and this value, the length and breadth will be the same. So the area will be given by 1 upon 2 root 2 multiplied by 1 upon 2 root 2, which is equal to 1 by 8. So the area of the square which is formed between these two parallel lines is given by 1 on 8. Now, we have understood the concept of slope before, where we had seen that the slope tan theta is y2 minus y1 upon x2 minus x1. Now, if we do not have the coordinates but we know the value of the slopes of the lines, then also we can say that the angle between two lines is theta, then tan theta is modulus m1 minus m2 upon 1 plus m1 m2. So for two lines, if the angle between the two lines, obviously these lines will be intersecting, that means they are not parallel to each other. So two intersecting lines having slopes m1 and m2, the angle theta between them, the value of tan theta is given by m1 minus m2 upon 1 plus m1 m2. Now, this question says find the equation of the straight line that passes through the origin and makes an angle of 45 degrees with the straight line root 3x plus y is equal to 11. So I'm given the equation. The equation of the line is root 3 times x plus y is equal to 11. Converting into form, root 3x plus y minus 11 is equal to 0. We get the value of a is equal to root 3, the value of b is equal to 1, and the value of c is equal to minus 11. Now, here we can see that the slope of this particular line, if I convert it into the format y is equal to mx plus c. Then y is equal, I can write y is equal to minus root 3x minus 11, right? So comparing it with y is equal to mx plus c, we get the value of the slope m is equal to minus root 3. Now, it is given that the angle between them is equal to 45 degrees. So, I can say tan theta is equal to m1 minus m2 upon 1 plus m1 m2, right? The angle theta is given as tan 45. So, tan 45 degrees is equal to the first slope minus root 3 minus the second slope m2 upon 1 plus minus root 3 into m2. Now the value of tan 45 is equal to 1. So I can say that root minus root 3 minus m2 upon 1 minus root 3 into m2 is equal to 1. So when we open this up, we will get minus root 3 minus m2 upon 1 minus root 3 m2 is equal to 1, or minus root 3 minus m2 upon 1 minus root 3 into m2 is equal to minus 1. Again, guys, remember, because of the modulus value, I have to equate it to plus and minus values both. So solving this equation, what do we get? So here we get minus root 3 minus m2 is equal to 1 minus root 3 m2. So I get minus root 3 minus 1 is equal to m2 minus root 3 into m2. So here I can say that root 3 plus 1 is equal to root 3 into m2 minus m2. So the value of m2 is root 3 plus 1 upon root 3 minus 1. Similarly, solving the second set of equations, I can say the values which I will get is 1 minus root 3 upon 1 plus root 3. Now you have got the slope, and it is given that it passes through the origin. That means it passes through x1 y1, which is equal to 0 comma 0. So using the format y minus y1 is equal to m into x minus x1, substitute the two values of m, take y1 is 0, x1 is 0, you will get two set of values for the equation of the line, and that's your answer. Now, supposing you are given three coordinates, right? We know that we can join 3 points and always get a triangle. So, supposing AX, BX, AX, BX, uh, AX, AY, BX, BY, and CX, CY. Supposing these are the three coordinates AX, AY, BX, BY, and CX, CY. Then the area of the triangle, which is bound by these three coordinates, is given by the formula on the screen. Guys, you can just memorize this formula. So if there are three coordinates ax and ay, bx and by, cx and cy, for these three coordinates, the area of the triangle between them is given by the formula on the screen. Now, the distance between any two coordinates is given by the formula x1 minus x to the whole square plus y1 minus y to the whole square, the whole root. So let's understand this formula. Supposing we have our coordinates, right? We have the first point x1 comma y1. We have our second coordinate x2 comma y2. So I need to find this straight line. Let's call them A and B. Now I can complete the right angled triangle here, where this C is my 90 degree. The value of this coordinate is x2. The value of this coordinate is x1. The value of this particular coordinate is y2, and the value of this particular coordinate is y1. Now, the length of AB is given by AC square plus BC square. The length AC, this length is nothing but the entire distance x2 minus this much distance x1. Similarly, the length BC is nothing but the entire distance y2 minus y1. So we get AB the length between the two coordinates is x2 minus x1 the whole square plus y2 minus y1 the whole square. So as you can see, this formula is nothing but the practical application of Pythagoras' theorem. So here are a few examples. If there are points A, B, and C given by the coordinates 1, 1, minus 2, 7, and 3, minus 3, what are the linear distances AB, BC, and AC? I've shown the calculations on the screen. You can do it on your own and confirm your answers with the one provided here. Now, let's do an example. It's given that two vertices of an equilateral triangle are 0, 0 and 2, 3, 2. You have to find the third vertex of this equilateral triangle. Okay, so we know that an equilateral triangle is nothing but a triangle where the length of all the three sides is equal to each other. That means length AB is equal to BC is equal to CA. Now, I'm not going to pay attention to exact marking of coordinates, I'm just going to mark them. So let's assume that 0, 0 is coordinate A, 2 root 3, 2 is the coordinate B. That means coordinate C is what we have to find out, and that can be x, y. Now, we know that AB, the length AB, can be given by under root of A minus B. So, under root of 0, so x1 minus x to the whole square, so 0 minus 2 root 3 the whole square plus 0 minus 2 the whole square. We get BC is equal to the coordinates B and C, so we get 2 root 3 minus x the whole square plus 2 minus y the whole square, and the length CA is given by x minus 0 the whole square plus y minus 0 the whole square. So take them two at a time. Equate AB and BC, solve it. Equate BC is equal to CA and solve it. Equal to AB is equal to CA and solve it. Once you simplify and solve this, you will find two set of values for x and y. So the value xy can either be given by 0, 4. The other set of values satisfying this will be 2 root 3 and minus 2. So solving this, there are two possible answers. Why do we get two possible answers? Because see, supposing we have the points A and B, the point C could be here, but alternatively, I could also have another triangle marked on the opposite side. So C could either be this point or C could be another point. And that is why we get two set of values which satisfy the given conditions. Next problem. It says that a line passing through A, to A and minus 2, 3 is perpendicular to the line 4x plus 3y plus 5. I need to find the value of A. So the given line is 4x plus 3y plus 5 is equal to 0. So I can say 3y is equal to minus 4x minus 5, or y is equal to minus 4 by 3 into x minus 5 by 3. Why did I do this? I'm converting into the format y is equal to mx plus c. So here I get the slope m is equal to minus 4 by 3. Once I get the slope minus 4 by 3, we know that when two lines are perpendicular, the product of their slopes is minus 1. So minus 4 by 3 into the second slope should give me minus 1. So solving this, the slope of the perpendicular line will be equal to 3 by 4. So once I know this, I know that the line is passing through a comma 2a and minus 2 comma 3. So I can say that y2 minus y1 upon x2 minus x1 is equal to the slope of the line, right? So y2 minus y1 upon x2 minus x1 is equal to the slope of the line. And once you solve this, you will get the value of a. So we get 12 minus 8a is equal to minus 6 minus 3a. So we get 18 is equal to 5a, or the value of a is equal to 18 divided by 5. That's the answer to this particular question. Let's do another interesting problem. It is said that the line joining 2 points 2, 0 and 3, 1 is rotated above a point A in the anticlockwise direction and then through the angle of 15 degrees. You have to find the equation of the new line. So the original line was passing 2, 0 and 3, 1. So the slope of this line y2 minus y1 upon x2 minus x1 is y2 minus y1 upon x2 minus x1, which is equal to 1. We also know that tan theta is the slope of the line 1. So if tan theta is 1, we know the value of theta according to trigonometry should be 45 degrees. Why? Because tan 45 is equal to 1. So we know that the original angle is theta 45. What does that mean? That this angle that it makes with the x-axis is theta 45 degrees. Now it rotates 15 degrees anti-clockwise. So 15 degrees anti-clockwise it adds. That means the new theta is 45 degrees plus 15 degrees. That is 60 degrees. So the slope of the new line is tan 60 degree, which is equal to root 3. So now if I know that the new thing is root 3, now it is already passing through 2, 0, right? Then just rotate it. And so pass slope 3 passing through 2, 0. So y minus y1 is equal to m into x minus x1. So simplifying this, root 3x minus y minus 2 root 3 is equal to 0 will be the value of the new line that is formed. I hope everybody understood this problem. The next problem, again a very interesting one. We have to find the equation of a straight line which is parallel to 2x plus 3y plus 11 is 0 and the sum of x and y intercepts is 50. It is given that the line is 2x plus 3y plus 11 is equal to 0. We know that if any line is parallel to this, it will be given by 2x plus 3y plus k is equal to 0, where k is what we are assuming to be the new intercept. Now, it is given that the sum of x and y intercepts is equal to 0. What do you mean by x and y intercept? It means the points where it intersects, where this line intersects with the x and y axis. So, at the x-axis, the value of y will be equal to 0. So, we get 2x plus 3 into 0 plus k is equal to 0. So, simplifying this, we get the value of x is equal to minus k by 2. Similarly, when x is equal to 0 for the y-intercept, 2 into 0 plus 3 into y plus k is equal to 0. So, we get the value of y is equal to minus k by 3. It is given that the sum of the x and the y intercepts is equal to 15. That means minus k by 2 plus minus k upon 3 is equal to 15. Solve this and you should get the value of k. Solving this, we get the value of k is minus 18. So the equation of the line becomes 2x plus 3y minus 18 is equal to 0. So the important thing to remember in this particular question is the x-intercept is found by putting y is equal to 0. Similarly, the y-intercept can be found by simply putting the value of x is equal to 0. Now, supposing there is a line given, right? We are given the line AB as shown in this figure. The coordinates of A and B are known. Now there is a dot in between. So that is a point which is dividing AB in a ratio. That point is dividing A and B internally in the ratio of m is to n as shown in the figure. So the coordinates of that particular point which is between A and B and which is dividing A and B in the ratio of m and n is given by the formula mx2 plus nx1 upon n plus n and my2 plus ny1 upon m plus n. So the formula to find the coordinates of a point which internally divides the line in ratios m and n is mx2 plus nx1 upon n plus n and my2 plus ny1 upon n plus n. Now, we can have a point beyond the line. The line is AB and the point is given on the extreme right. It is dividing AB from outside. So from A to the point, the length is M, and B to the point, the length is N. So then, in this case, the coordinates of this point, which is outside, is given by mx2 minus nx1 upon m minus n and my2 minus ny1 upon m minus n. So remember guys, the formula, you have the addition if the point is between the two given coordinates, internal division, and the formula contains minus signs when the dividing point is outside the given coordinates, when the division happens externally. So let's take this problem. The ratio in which the line segment joining 2 comma minus 3 and 5 comma 6 is divided by the x-axis, right? We have to find the coordinates of the point at which the line segment intersects the x-axis. So I know that my points are 2 comma minus 3 and 5 comma 6. Let's take a visual representation of this, right? So the point 2 comma minus 3 will be 2 and minus 3. So this is my first point, 2 comma minus 3. My second point is 5 comma 6. 1 2 3 4 5. 1 2 3 4 5 6. So it will be this point. So this point is 5 comma 6. So I can have a straight line joining these two things. The point is, I have to find the ratio in which the line segment joining them is divided by the x-axis. Now this is my x-axis. So x-axis at this point, we know that y is equal to 0. So the first thing that we do is find the equation of this line. The equation is y minus y1 upon y1 minus y2 is x minus x1 upon x1 minus x2. So let's take the equation y minus y1 is minus 3 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. So we get y plus 3 upon negative 9 is equal to x minus 2 upon negative 3. Minus and minus gets cancelled, 3 and 3. So y plus 3 is equal to 3x minus 6. So 3x minus, so equation of the line can be formed as 3x minus y minus 9 is equal to 0. Now, at the point of intersection, we get the coordinates. Now, the coordinates at this point, y is equal to 0. So, we get 3x minus 9 is equal to 0 or 3x is equal to 9. So, x is equal to 3. So, the coordinate of this point is 3 comma 0, right? Now, this point 3 comma 0 is internally bisecting. So, the formula is, the bisecting point is mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. What you can do is substitute the values. This is x1 y1, this is x2 y2. Substitute these values in this particular equation and you will find that m is to n comes to the ratio of 1 is to 2. Quite simple. So one last point before we call this session to an end. Supposing we have the coordinates of three points, they form a triangle. Then the coordinates of the centroid. Now, guys, centroid is the point of concurrence of the medians. What is a median? In a triangle, the line that joins a vertex to the midpoint of the opposite side is called a median. So, three vertices can project three medians. The point where all three medians meet is called the centroid. So if you know the three coordinates for the vertices of a triangle, then the coordinates of the centroid is given by x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. For the sake of example, if the coordinates are 2, 3, 4, 5, and 6, 7, then the centroid is 2 plus 4 plus 6 divided by 3, which is equal to 4, and 3 plus 5 plus 7 divided by 3, which is equal to 5. So the centroid here is 4 comma 5. So these are the important points in coordinate geometry that you're expected to remember. You can practice such simple examples, and cracking these problems in the examinations is going to be quite easy. Wish you all the best. Have a good day.